Welcome to the Podkey summary of what's new in Swift from WWDC 2026. This week in Swiftland, a lot of the updates are the kind you only notice once they save you from something annoying. There are cleaner ways to handle naming collisions, better tools for mixed test suites, more control over compiler warnings and optimization, and a bunch of performance-minded additions that feel very aimed at real-world code instead of flashy demos. And on the lower-level side, Swift keeps pushing into C Interop, WebAssembly, and embedded systems without losing sight of developer ergonomics, which is a pretty nice trick. One of the most immediately useful changes is the new double-colon operator in Swift 6.3, called a module selector. Its whole job is to tell the compiler, very plainly, that the thing on the left is a module name, not a type. So, if you've got an import collision like Rocket Saturn V versus Rocket Saturn V, you can disambiguate it without playing guessing games with the compiler. It also works for methods and properties, which matters if two libraries both ship something called Vue. And of course, one of them is probably Swift UI, because Swift UI loves a very confident noun. The Swift team's advice is sensible here. Use the feature when you need it, but don't build APIs that depend on collisions being resolved this way, because docs and error messages can still get murky. There's a similar cleanup move with availability annotations. A new token called Any Apple OS lets you collapse the usual stack of iOS, macOS, tvOS, and watchOS availability into one line when the same rule applies everywhere. If one platform needs an exception, you can start with the broad Any Apple OS declaration and then add the specific carve-out, and it works in hashtag if OS checks too. It's not dramatic, but it does remove some repetitive code that nobody was ever emotionally attached to. Swift is also getting much more precise about diagnostics. The new @diagnose attribute lets you turn a specific warning group on or off for a single declaration instead of making a project-wide decision. So if one function legitimately needs to ignore a deprecated declaration warning, you can silence that one spot without muting the rest of the app. Or you can do the opposite and crank up scrutiny in a sensitive area, like enabling stricter memory safety checks only inside security-critical code. It can even promote future error warnings into hard errors right away, which is handy if you want to clean up now, instead of letting little problems age like milk. There's also more explicit optimizer control in Swift 6.4. You now get @inline always to go with @inline never, so developers can force inlining when they know it's worth it. And @specialized lets library authors ask for specialized versions of generic functions for concrete types, especially in cases where the optimizer can't infer enough from usage alone. That's the kind of feature that won't matter to every app developer every day, but when it matters, it really matters. A very practical concurrency addition is the new task cancellation shield in Swift 6.4. Inside that shield, cancellation checks always report false, which means a canceled task can still finish a tiny piece of absolutely necessary work, like flushing a file or completing rollback logic. The important guardrail is that this is meant to be short-lived. It's for the minimum cleanup region, not for pretending cancellation never happened and wandering off into more work anyway. Foundation is also getting a new progress manager type, built for async and await. It separates progress composition from reporting, supports type-safe metadata, and because the implementation moves into Swift instead of leaning on older Objective-C APIs, it's faster and uses less memory. And for subprocess handling, Subprocess 1.0 now exposes alkunat and Gasperset as async buffer sequence values. That guarantees each stream is created exactly once and consumed safely, which is a big improvement for code that launches tools and reads output as it arrives. There's also a strings method that reads line by line while respecting grapheme cluster boundaries, which is one of those details you're very happy somebody thought about before your logs start eating characters. The testing story got a nice interoperability boost too. In Swift 6.4, if you call XT-test assertions from Swift testing, assertion failures are reported as test issues instead of disappearing into a migration gap. That means teams can move gradually without losing coverage or messing up results reporting. It works in the other direction too. Swift testing macros like #expect can be used inside XC test case. And if a team wants to be stricter about the boundary between the two systems, Xcode build settings can promote the interop warnings into hard failures. That's a pretty thoughtful migration path, because most real code bases are mixed for a while, no matter how clean the greenfield slides look. A smaller but very welcome standard library addition is map keyed values. Unlike map values, it gives the closure both the key and the old value, so you can transform a dictionary based on both without rebuilding the whole thing yourself. It's clearer, more expressive, and avoids a bunch of awkward dictionary work that used to feel needlessly manual. There's also meaningful progress in Swift's ownership model. Non-copyable types can now conform to equatable, comparable, and hashable, and protocols can declare associated types that are non-copyable or non-escapable. That opens up more high-performance designs without forcing everything into copyable shapes just to satisfy protocol requirements. Swift 6.4 also introduces an iterable protocol that for loops can use to borrow elements in batches, avoiding copies and extra reference count overhead compared with traditional sequence. And then there are ref and mutable ref. Ref gives you a borrow of a single value, while mutable ref, created with ampersand syntax, gives exclusive mutable access with lifetimes enforced at compile time. A concrete example is holding onto a dictionary entry across a loop without repeated lookups, which replaces an older in-out trick that worked, but definitely had the vibe of knowledge passed down in a cave. Swift's reach outside the usual app sandbox keeps growing too. The new @C attribute is basically @OBJC for pure C. It lets Swift functions be exported with C-compatible signatures without needing separate header writing gymnastics, and the compiler checks that you only use C-compatible types like integers, pointers, imported structs, and raw value enums. That's a good example of safety and convenience actually moving in the same direction. On the web side, recent JavaScript kit work replaces dynamic lookups with statically typed bridging, and the benchmark from GoodNotes shows a 35 to 40 times speed up for safe WebGL calls from Swift-compiled WebAssembly. That's a huge jump, especially because the goal wasn't to drop safety checks and hope for the best. It keeps the safety guarantees and still gets close to native JavaScript performance. The trade-off, as always, with Swift to WASM, is binary size. You get code reuse across iOS, backend, and web frontends. But that WASM binary has to be downloaded on each page load, so size becomes part of user experience, not just a build metric. The recommendation there is pretty grounded. Use CDNs and aggressively prune unused modules, because oversized bundles can burn bandwidth fast. And finally, for embedded Swift, type layout metadata now lives in dwarf debug info instead of the firmware binary itself. That keeps firmware small while still making post-mortem debugging from a core dump much more useful on constrained devices. If you work close to the metal, that is the kind of change that can save hours of staring at a crash and wondering what exactly just exploded. So overall, this is a very tools and infrastructure-heavy batch of Swift news, but in a good way. A lot of it is about making large code bases easier to maintain, migrate, optimize, and debug, which usually ends up mattering longer than the flashy stuff. And honestly, any release that removes boilerplate, avoids weird compiler ambiguity, and makes tests less fragile is doing solid work. This episode was generated by Podkey. Create your own at podkey.fm.